Right, so you saw in the previous example I was feeding the little microcontroller and the supercapacitor from a power supply, and I'd upped the current, and you saw that it ran continuously. That's fine, but that's hardly energy harvesting, which is really what I'm talking about here. So I've got a slightly different circuit here, same setup, that's still an ATtiny in there, but this time you can see I've got a loop, and that loop has an impedance of about 50 ohms at around about 500 kilohertz, and what that means is that little coil is receiving that energy and putting it into, that's not a terribly super capacitor, that's about 100 microfarad, what you might call an ordinary electrolytic capacitor. And what that means is, if you look on the scope there, you can see the DC, it's the wrong way around, but increasing and then fire, increasing and then fire in a second. Yeah. So increasing, LED about to fire. You see that on the camera? Yep, just about saw that. So the same principle. So we've got energy coming in. Okay, it's a sine wave. We're using electromagnetic coupling, and picked up by that coil, magnetic resonant coupling, picked up by that coil, accumulated. There's you look on there, there's two little diodes, so they're germanium, or geranium as I like calling them. So two geranium diodes, full wave rectifying onto the ordinary capacitor, and the microcontroller is taking care of the energy management, same as before. Not enough on the super capacitor, on the ordinary capacitor rather, to light the LED. The microcontroller goes to sleep. If there's enough, it fires, and then takes another measurement and goes to sleep. So quite clever, and you can imagine that being an RFID device, which is what this research is all about. Obviously what the things we're making are considerably more sophisticated than this, but that's the basic principle behind it. So as soon as we beam energy onto that, that microcontroller comes alive and stays alive. So if you look on the, again on the scope screen, you'll notice, hopefully you'll notice on 2 volts, you'll notice that it doesn't dip below 2 volts. That means that microcontroller is alive, permanently alive. It just sits there taking care of itself. Its program counter's running, and it's okay, it's having a little sleep every 8 seconds and then waking up, but nevertheless, for all intents and purposes, that's working. That's fully operational all the time. So kind of the scenario is that you've got an RFID tag, but it's passive active. In other words, it's batteryless. You'll notice there's no battery on there, and all the energy's coming into that coil. This is a batteryless solution, and it's kind of energy harvesting, but I'm injecting the energy, I acknowledge that. But it's receiving the energy, rectifying it using the germanium diodes, putting it onto the capacitor, and then finally the ATtiny is doing the intelligent work and measuring what's on the capacitor, deciding whether it's time to fire and light the LED, or whether it's time to go to sleep again. And that cycle just continues indefinitely. Of course, if I turn off the source of the RF, which is coming from that big coil, then of course the little microcontroller eventually dies. It'll run for 20-30 seconds from a capacitor that size, but eventually it'll under voltage and the poor little chap will die. But as soon as we inject a bit more RF into that coil the next time round, it comes back to life and it does its little job of flashing that LED. Okay, so a bit like the RFID tags that you get in the libraries and in the shops to prevent shoplifting and so on, but this one we can actually write a program on instead of just having numbers on it. Okay, I hope that makes sense to some of you. Bit advanced for a lot of people I know, but it's a nice little demo there that I put together yesterday, and I thought I'd just show everyone it working. And you can hear the other one in the background defiantly going just as it was before. Okay, so that's been running a day and a half, that one, and that one's been running overnight. Perfectly happy. And store. Come on, fire. Fire. Store and fire. Okay. If you mail me, I can give you the code, but it's no big deal. It's just done in Arduino, and I think you can probably work it out for yourself. Okay, that's my weekend. Bye for now.